Today we're going to go ahead and start talking about multiplying polynomials. But before we can talk about multiplying polynomials, and we're going to be talking about it using algebra tiles, before we can start talking about that, let's go ahead and think back a little while when maybe you were learning about the distributive property in 6th grade, maybe before. What your teachers may have shown you is that when we have two rectangles put together, both of them have a width of 12, okay? And one has a length of 60, the other has a length of 6. To figure out the total area of this rectangle, if we put the two together, I would say that 12 times the 20, and I would get the 240. And then that 12 times the 6, and I would get 72. And so I would end up with an answer of 312, if I'm not mistaken. So that's how we would figure out the area, and this was kind of how your teachers may have introduced distributive property to you. Same here. I have a length of 1, a width of x, and another length of 1. So I'm going to multiply that 1 to the x where I have x, and then that 1 to the 1, and I get 1. Now, just like here with 240 and 72, if I look back, I had to add those two together. So 240 plus 72, and that's how I got 312. Here, I have a variable and a constant. I can't really combine those together, so I would just say x plus 1. So let's go ahead and kick this up a notch, maybe. Okay, whoops. So here, I have 2 times 3. So I would take my blocks, and I would go ahead, and that 1 times that one is 1, and 1 times that one is 1. 1 times the other one is 1. 1 times the other one is 1. And 1 times that last one is 1. See how I made a rectangle? Okay, it's not perfect, I know. But see how I made a rectangle? And to figure out that 2 times 3, we could look at it visually to figure out it has an area of 6. Let's go ahead and kick this up a notch, okay? And here's where your notes begin. So we have example 1. Let's go ahead and look at example 1 here. For example 1, what I have here is x times x plus negative 1. Okay, x plus x times negative 1. Real quickly, let me throw this reference out for you so you can see. Okay, so if it's a square, it's x squared. If it's just a single bar, it's an x. So if it's a single red bar, it's a negative x. Same with the red square, it would be negative x squared. And then the yellowish color is 1, and then the red square would be negative 1. Okay, so we have that to use as a reference. So here I have x times x plus 1, and that's how we would write it, x times x plus 1. Now, we've done a lot of this math already where we distributed the x to the x and distributed the x to the 1. But we can also look at it visually using these algebra tiles where x times x, this bar and this bar create a larger square. And then this bar and this small tile create a rectangle. And so we would end up with an answer of x squared plus x. This is our x squared. This is our plus x. Okay? So let's go ahead and try another example. I'm going to erase this, and I need to pull down example 2. You have another page on your notes that you can just move on to. So now let's go ahead and look at example 2. For example 2, I have negative x times x minus 2. And the reason why I did it that way instead of x minus 2 times negative x is just showing the order, okay? If you said x minus 2 times negative x, that's perfectly fine. I just rewrote it. Remember, we have the commutative property where I can change the order around, no big deal, and set it up. Now, we need to remember, a positive times a negative. That's how we end up with this negative x squared. Okay, and then we have a negative times a negative. That's how we end up with that positive x, and that negative times that negative, I end up with a positive x. Again, we're still creating a rectangle. So if we look at it, here I have negative x squared plus, or I would say, yes, plus 2x. Let's look at it up here the way I wrote it out that we're more used to. Negative times a positive would be a negative x squared. Negative x times negative 2 would be a positive 2x. So it works out either way. This is just giving us a visual way to be able to recognize it. Again, I'm going to erase example 2. You can just move on to the next page in your notes. Goodbye, example 2. So let's go ahead and take a look at example 3 that we have here. Now we're going to kick it up a notch. Okay, so I have x plus 2 times x plus 1. Now what we're doing is we're multiplying binomials, okay? We're going to talk about this more in class, but this is going to be the visual way we can see this, okay? So what I'm going to end up with is, let's see here, I end up with a big X. I guess I could drag the little things over instead of drawing these little pictures here. I'm going to end up with a big X. All right, a positive times a positive gives me a positive X. Okay, see how that works out? And then I have this positive and this positive. I don't see any tiles that I can rotate. Let's see. I don't think that's yes, it is. We can rotate that, where this guy ends up like that. And we end up, let's see, we have this. I'll bring this guy down again, rotate him. This guy ends up like that. Well, I don't have a perfect rectangle yet. I got to multiply my individuals out there too. That's a positive times a positive. So I have this, and then a positive times a positive, and I end up with this. Now let's see what I have here. Okay, I have x squared plus 3x. There's 1, 2, 3 of them, plus 2, and we're done. Pretty easy way to be able to see how to multiply these two together. Okay, and like I said, I'm going to show you other methods in our next class, but I want you to be able to see this algebra towel in your notes. We'll talk about algebra towels a little bit in class, but then we're really going to focus on the other methods that we have to do this with. Okay, I'm going to erase example 3. You move on to your next example, or your next page of notes, which is example 4. I guess I get to put all this in the trash. Goodbye. Maybe? Maybe? Go away. There we go. Maybe? Okay. So, example 4. Whew, here we go. All right, I have a positive and a negative x. So a positive times a negative is a negative. There's my negative x squared. And make sure you're drawing these on your pages, okay? I don't have the capability. And what I would do is I would just draw the rectangle and put a negative in it so you understand that it's negative, okay? So I have a positive x and a negative 1, so it's going to be a negative x and a positive x and a negative 1. There's another negative x. And then I have a positive x and a negative x and a positive 1. So that's going to be negative again, right? And a positive times a negative. I get this. And then I have positive times negative individual, so that's going to be a bunch of negative values there. Whew. Turned all red, huh? Okay, so I forgot to write this down. If I have, let's see, x plus 2 times negative x minus 2. That should have been the polynomials that I'm writing down to multiply, or the binomials that I'm multiplying. Okay, so let's see here. I have negative x squared, 1, 2, 3, 4, minus 4x, 1, 2, 3, 4, and I would say minus 4. There we go. Negative x squared minus 4x minus 4. And that would be our answer. Another way that you might see this represented is the negative sign on the outside, x squared plus 4x plus 4. I've seen people represent it that way as well. Okay, same thing, exact same thing. Okay, let's go on and let's take a look at a couple of practice problems now. Okay, so let's take a look here. We have, all I really want you to focus on is 1, 2, 3, 4 on this page. I'm not too worried about the problems down below. Okay, so here I have, it looks like negative 4 times x plus 3. So here we would have a lot of little squares. A lot of little squares. And they're all going to be negative. So I'm just going to put a negative symbol in them. And then all of these negative ones times this x and all of these are negative because it's a negative times a positive. So when I end up with that, I end up with negative 4x minus 12. Moving on to number 2, I have a positive x. Let's see here. It says x plus 3 times x plus 3. Now that kind of reminds me of, let's see, that's the same thing. Could I say x plus 3 squared? I don't see why not. So that's one, you could write it one way or the other way, okay? So let's see here. I have, and this is why, okay? A lot of you guys were wanting to go ahead when you saw this x plus 3 squared or something similar to it. You wanted to make it an x squared plus 9. A lot of you were wanting to go ahead and just go ahead and do that. But we can't do that to solve this. It's going to end up as x squared. And then I've got to multiply this positive x here. And then I've got to multiply this positive x here. And then I have all of these individuals. And you guys were okay when it came to the x squared plus 9. But the part of the answer that you guys were missing was the 6x. Okay, that's the part that you were missing. So we end up with x squared plus 6x plus 9. Okay, like I said, when you guys looked at this problem, you guys were good with the x squared and the 9, but the part that you guys didn't realize is that there's more to it than just that. Again, we'll get more into it in class next time. If you would, please try 3 and 4 on your own. And on to our last slide of our notes here. I'm going to go ahead and do 1 and 8. I'm going to ask that you do 2, 3, 4, 9, 10, 11. Okay, I'm going to ask that you guys do those. So I'm going to ask that you do 1, 2 problems on the previous slide and 2, 4, 6 problems here. All right, so I have x plus 5 and x plus 3. So I end up with my x squared, and then my positives here, and my x squared and my 5 positive x's here. And then I have all of these 15 little squares that, you know, you want to draw in. If I can do it, so can you. Okay, some of my squares look a little strange, but that's okay. Don't have to be perfect. So I end up with an answer of x squared, 1, 2, 3, 4, 5, 6, 7, 8, plus 8x plus 15. All right, so here I have 2x minus 4. I'll put minus signs in all of those. And then I have x plus 5. All right, so let's see. So there's an x squared, there's an x squared. And then I have these negative x's here. Negative, 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 negative. And then I have all these positive x's going on here. There's 5 in this row. And then 5 in this row. And then I have negative 4 and positive 5. So you get to write out 20 of these. And they are all going to be negative. Negative, 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 negative. Okay, so let's see here. I have 2x squared. I have positive 10 x's here, but negative 4 x's there. So I'm only going to, so what that means is that these 4 cancel out and these 4 cancel out. Okay, because a positive and negative cancel out. So I'm going to end up with plus 6x, and then I have minus 20. All right, go ahead and try the others on your own. Good luck, and we will talk about it when we have class on Monday.